When the workhead uses the pressure plate, the depth mode will be used. This determines how deep the screw will be tightened. Loosen the side screws. By going up or down, determines the depth of the screw. When the ejector pin is upward, the screw tightening depth is shallow. When the ejector pin is downward, the screw tightening depth is deep. The sensor stops descending when it senses the push rod. At the beginning, we first adjusted the push rod upward to prevent the LED module from being crushed. Then we use a single step to tighten the screws. Before working in a single step, debug the working speed to the lowest. Turn this speed down. After selecting, press OK. Then reduce these 3 speeds. After the speed is reduced, press OK. Next, we use a single-step method to assemble the screws. After selecting the coordinates, press single step. Look. Do you know why the screws didn't come off? We manually remove the screws. The screws still haven't come off. Because the set number of rotations of this motor has reached the target value, it stops working. The tightening torque, the number of revolutions of the motor, and the depth of the Z-axis down, any one of these 3 signals is reached first, the work stops. It is now that the motor has reached the target number of revolutions, so it stops working. So we are going to set the number of revolutions to a lot. We changed from 12.8 to 99 laps. Saving values. We adjusted the value very large, meaning that we blocked the signal. Next, we single-step test. Now the screw assembly effect is no problem. Let's take a closer look at the status. Let's debug this height and see what the effect will be. Adjust the ejector rod upwards and check. How about we check the screws using single step? Look at this screw, it's not unscrewed, it's protruding. Because the push rod is upward, the screw is also protruding. Assuming that the screw protrudes upward by 2 mm, the ejector pin should be adjusted downward by 2 mm. After debugging, it looks like this. Do not debug a lot at once, as it may be easily damaged module mask. You see, I debugged it downwards to see how the screws are assembled. You see, this is because the downward debugging distance is too much and it is damaged. The heads of the screws all sank. This is not good. The best condition is that the end of the screw is on the surface of the module mask and cannot crush the mask. This downward debugging is too deep and needs to be debugged upward. This distance needs to be adjusted slowly. Which screw assembly achieves the best effect? Look. This one, the screw is on the surface. Mask, no pressure deformation. The downward distance of the screw just now is too much, let's adjust it upward. Look, there is no problem with tightening this screw. Next, let us introduce the number of rotations and torque. Click the Login button. Select Admin User. Enter Administrator password. Click on the Task Management menu. This is all the parameters all turned on. We will only use 3 parameters: torque, number of rotations, rotation speed. Do not set other parameters. Normally, we only adjust this target torque. For other parameters, just use the default parameters. If the number of rotations is not enough, let's adjust the number of rotations. We were debugging single stepping just now because the number of rotations was not enough. Then this is the speed. This is the rotation speed of the motor. It rotates 1000 times per minute. Take a look here. The current actual number of rotations will be displayed here. It also displays the torque and the locking status of the screws. If the target number of turns we set does not actually tighten the screw, we need to increase the number of turns. If the screws are not tightened, insufficient torque will also affect it. The machine's judgment method is that if any signal reaches the target value first, the machine will stop.